Welcome to Pure Mathematics 1, Pearson Edexcel A level, so AS level. So usually we use the specification and we go topic by topic, but for this we will use the textbook and go topic by topic through this, okay? So let's start from the beginning. Index laws. Okay, index laws, there are a few laws that we need to know. There is AM times a to the power n will be m plus n, okay? An example, x cubed times x to the power 6 will be x to the power cubed plus 6 will be x to the power 9, okay? That's one. Secondly, a to the power m divided by a to the power n is equals to a to the power m minus n. An example again, a to the power 7 divided by x to the power 4 will be x to the power 7 minus 4. That will be equals to x cubed. That is the second law, and the third law is a to the power m, and then power that again by n. This will be equals to a to the power m times n. An example of this, x to the power 9 cube root that, you get x to the power 9 times 3, which is x to the power 27, okay? Those are three rules that we have to know. Remember, if the powers are not multiplied and rather added, so a to the power m plus a to the power n, it will stay the same, plus or minus. So if it's not plus, then it's minus, and it'll stay the same, okay? Those are the laws we need to know. An example of the question, let's just take a quick, yet slightly hard example of this. Let's take an example, 9x to the power 5 minus 5x cubed divided by 3x, okay? So automatically you will simplify this. You'll write 9x to the power 5 divided by 3x minus 5x cubed divided by 3x. This will become, so 3 goes, it becomes 9. 9 divided by 3 is 3, and 5 divided by 3 will stay that, so it'll become 3x, and then 5 up here, and 1 down here. So since it's divided, it'll be minus, so 5 minus 1, 4, minus 5 over 3. Here it's 1, here's 3, 3 minus 1, x squared, okay? That would be answer. You don't need to simplify it further, okay? That is the index laws. Expanding brackets now. Let's take an example. Let's say x minus 3, x squared plus 5x plus 4, okay? What you will do is you'll go term by term and you will multiply each of these. Then you will come back to this and multiply this term by term as well. How do we do this? You'll write x and then x squared plus 5x plus 4 minus 3, and then you write again x squared plus 5x plus 4, and you simplify all of this, you get x cubed. You multiply each one by 1, x cubed plus 5x squared plus 4x, that is this, and then minus 3x squared minus again because it's minus 3 minus 15x minus 12. And then you simplify all of this again, x cubed. These two terms are similar. 5 minus 3 is 2 plus 2x squared. 4 and 15, minus 15, sorry. That'll be minus 11x. And then we have a single and lone minus 12. This will be a simplified answer for the expansion of that. It's really only that. Now, factorizing. For factorizing, what we will need to do is, it's basically going backwards. Instead of simplifying, we will be going backwards now. Let's take an example, x squared. Let's take an example that we can truly identify. Let's go simple first, okay? X squared plus 5x. How do we simplify this, okay? How do we factorize this? Just take the x outside, x plus 5. This is the factorized form of this. Factorizing basically means putting it into brackets and simplifying it as far as you can. Yeah, there's that. Next up, let's take 2x squared minus, 2x squared plus 5x minus 3. The sum will be b, so sum is equals to 5, and product is a times c, that is 2 times negative 3, product is negative 6. What two numbers give a sum of, when added a plus b you get 5, and when multiplied a times b you get 6? That will be, you essentially think of a number that relates like that. You will get 6 and minus 1, because 6 minus 1 is equals to 5, and 6 times negative 1 will be equals to negative 6, okay? So basically just think of this, and you get 6 and minus 1. you put this into this. Instead of 5x, you write 2x squared plus 6x, and then again minus x because minus 1 comes here, so minus 1x, and then you write the 3, so it becomes minus 3. And then like we did above here, you will factorize it, so 2x outside, x plus 3 inside, minus, and whatever you have here has to be the same in the other brackets. So if we take minus outside here, what do we get here? You get x plus 3, because when you open this, it becomes minus x, which is over here, and you get minus 3, which is also over here. This is basically how we expand this, but then you can expand this further. This is minus 1 outside here, so you join this with this, so you write 2x minus 1, and then you write 1 of the 2, which is both the same, so you write x minus 3. You can confirm by expanding that, but this is very quick, so that is basically how you do that. Negative and fractional indices. Now, negative and fractional indices, basically, there are some rules that we need to know here. Let's just write them down. A to the power 1 over m will basically be a root m. What does this mean? Let's not have 1 now. Let's have a to the power n over m, okay? This will be equals to a to the power n root of m. Let me use an example for it to become a bit better. What if we have x to the power half? We all know that this is root x. But why is it root x? There's a 1 here and there's a square root. So that's how it becomes that. X to the power 1 over 3 will be x1 cube root of x. Let's say we have x2 over 3. So the top number will become in the root, and then the below number will come outside the root and become 3, okay? That's how we do that. Now, what if we have a to the power minus m? That will essentially mean 1 over a to the power m. An example of this, a to the power negative 1 is 1 over a to the power 1, which is just 1 over a. X to the power negative 3 is basically 1 over x cubed. That's all that we need to know from that. And remember, any number to the power 0 is always equals to 1. So that is 100 to the power 0 is equals to 1. 0.01 to the power 0 is equals to 1. Always, okay? So yeah. That is that. Now we can just stick that again. Surds now. So for surds, what we need to do, a surd is basically a rooted number, okay? That's the simplest way to say it. It's basically a number that is in a root form. So root of n is what is known as a surd, okay? Surds are examples of irrational numbers. Examples of surds: root 10, root 7, root 6, not root 6, because that, okay, yeah, root 6, and so on and so forth. There's also like 10 root 2 and all that stuff, but let's just continue. So root AB will be equals to root A times root B. An example, root 50 is equals to root 5 times root 10. You can put this in the calc and confirm it'll give you the same thing. That's why when we're doing, like, let's say root of 8, we get root of 2 times root of 4, and root of 4 is 2, so it becomes 2 root 2, okay? That's essentially how we simplify this one. Yeah, also, likewise, root of a over b will be equal to root a over root b. Example, root of, let's say 7 over 9 will be equals to root 7 over root 9. You can simplify this again. Root 9 is 3, so become root 7 over 3, okay? There's that. That is done there. Rationalizing denominators. We could have taken this example, but it is root 9 which can be divided, but let's say it's root 7 over root 11. How do we rationalize the denominator? We multiply by the denominator on above and below. So root 11, we get 7 times 11 will become, remember this rule up here? Remember this rule here? So it become 7 times 11, that is 77, root 77 over 11 times 11 rooted is going to be 11. Remember, 11 squared, the square and the root cancels, so it become 11. That's how we rationalize those denominators, but remember, there are more. how do we rationalize larger denominators like root 5 plus root 2 over root 5 minus root 2? We use something that is inverted, okay? So we take the denominator and we change the middle sign. So if it's positive, you change it to negative and you multiply. So in this case, we will multiply it by root 5, but this is a negative, so we put it positive, okay? Root 2. It's likewise above, we use the same. Remember, when we're multiplying by the same number up and below, it is basically like multiplying it by 1, okay? So the value of the number doesn't change. When we multiply this, we get, remember how to multiply like this and like this. You get root 5 times root 5 is 5, plus root 5 times root 2 is root 10, plus root 10, plus 2. And then below it is going to be, this is basically going to become, remember the equation, a plus b, a minus b. It's basically a squared minus b squared, okay? The simplified version. You can expand it your own way, but that is basically how that is a rule that is known, okay, in your O levels. Anyways, root of 5 squared is going to be 5 minus root of 2 squared is going to be 2. So simplifying this, it's going to be 7 plus 2 root 10 divided by 3, okay? That is done. We are done with the first chapter, algebraic expressions. Let's move on to the second chapter, which is quadratics. So solving quadratic equations. We did this just before when we were doing the solving of the quadratic equation. Let's take an example again. X squared minus 2x minus 15 is equal to 0. How do you solve this? B is your minus 2. So let's take the sum to be minus 2 and the product will be equals to, there's a 1 here, so it'll be 1 times negative 15. You multiply these two and you get negative 15. What's two numbers are similar? Think of factors, okay, of 15. And you will think of 5. You can think of 5 times 3 is equals to 15. But what is negative now? If we take negative 5 times 3, we get negative 15. And also negative 5 plus 3 will be equal to negative 2. So let's solve this equation. Negative 5 plus 2, negative 5 times, plus 3, negative 5 times 3 is equals to that, okay? Let me just wrap this full stops. Yeah. We substitute the negative 5 and the 3 in place of the b, which is minus 2. So you get x squared minus 5x plus 3x. This totals to become negative 2x, so it's basically equivalent. Minus 15 is equal to 0. Factor out x in the first term, x minus 5. Remember, it has to be x minus 5 again. So what do we put here? To make it equals to this, we will basically put plus 3, okay? Bring these two terms together, x plus 3, and then put this term down here, x minus 5. That is how you simplify that very quickly, okay? Yeah, that is how to solve a quadratic equation. Completing the square. So when you're completing the square, there's a certain formula that we use. That formula is x squared plus bx is equals to x plus b over 2 whole squared minus b over 2 whole squared, okay? Yeah, there's that equation. Now, how does this equation basically make sense is what you're asking. If there's a 5 here, you will basically factor out the 5. Let's take an example. It'll be better if we take examples, okay? X squared plus 8x. Simple. Let's use this equation. B is equals to 8, so it'll be x plus 8 over 2. It's going to be 4 squared minus 8 over 2. This is also going to be like this, so it's going to be 4 again. And 4 squared is 16. That is how you make that the square of this, okay? Yeah. Next up, let's say that it is not x squared and it's 2x squared minus 12. What do we do now? Now we have to factor out the 2. We have to make it into form of x squared. So we'll do 2x squared minus 6, okay? 6x, sorry. Simplifying this, what do we get? We get, now we do our normal thing, okay? So here it'll be x minus, this is, so b is now equal to negative 6, so it'll become minus 6 over 2, which is minus 3 squared minus 3 squared again. This is x minus 3 squared minus Negative 3 squared is 9, okay? And then 2 of this. So it's 2x minus 3 squared minus 18. That's how we do that, okay? Yes. So yeah, that is that. Next up, what if we have another term, okay? Let's say it's 3x squared plus 6x plus 1. How do we complete the square for this now that there is a plus 1 here? What we will do is we will first factor out the 3 again. So 3x squared plus 2x. We do it still there, and then we just write plus 1 outside. So plus 1 is not affected by the 3. So yeah. So how do we do this now? We will basically do our normal method here. So it'll be x plus b is equal to 2. So b over 2 is 1. So 2 over 2 is going to be 1 squared minus b over 2, 2 over 2, 1 squared again, which is just 1. This is going to be in the brackets, and then 3 is going to be here. Plus 1 is going to be outside. So it's going to be 3x plus 1 squared. This 3 is going to come here, minus 3 plus 1, which is 3x plus 1 squared minus 2, okay? That's how we do that. That is how to complete the square. That's everything you need to know for completing the square. Next up is functions. A function is basically a relationship that is mathematical that maps each value to a set of inputs to a single output, okay? Now, the set of possible inputs is what we call domain, okay? And the set of possible outputs is what is known as range. What do we mean by this? You have the input numbers, x, y, z. You have the output numbers, p, q, s. And you have a function. This is basically x plus 3, z plus 3, y minus 6, and x squared plus 3x. These are known as functions. The input is known as the domain, and the output is known as, or the final value is known as the range. Okay, let's take an example. Functions of f and g are given. Remember, most of the work I'm doing is from the textbook, so it's basically a verbal explanation of everything that is in the textbook, okay? Let's take an example. Gx equals to x squared minus 9, okay? Now, first of all, what is, let's take a more complex one, okay? Because we have to move on time. Fx is equals to x squared plus 6x minus 5. Now, how do we find what do we find with these values, okay? The question on this is not really right, but basically this is what you call a function. In the exam, you will be told this is a function, and then what is the domain? Domain is the x values. This is the domain, and range is always the y values, okay? Y or fx. In this case, it's fx. Some equations will have y is equals to x squared plus 6x minus 5. So in that, it will become y, not fx. But that is basically the range values, okay? Let's give an example. Fx is equals to x over, let's not put x, let's put 5 over x minus 3. Now, the domain x cannot be equals to 3, because if it is 3, then this would be the denominator would be 0, and 5 over 0 is infinity, which is not possible, so that is the domain. What is the range? If you draw a curve of this, you basically get the range, okay? You get the minimum value, the maximum value, and all that stuff. Yeah, that's how you basically do this. So yeah, how do we move? Yeah, so that's basically what introduction to functions are. Quadratic graphs. F of x is equals to ax squared plus bx plus c. This equation basically looks like this, okay? Now, it's very important that we know a few rules. If your a is positive, your graph will look like this. And if your a is negative, your graph will look like this. So positive value is a U, negative value is an N. How do I think of this? Negative, negative, N, N, okay? That's how I think of it. That's how I memorize it, okay? Yeah. How do we draw these things, okay? Let's give an example. Y is equals to x squared minus 5x plus 4. Let's use our simple rule. Sum is equals to b, which is minus 5. Product is equals to 1 times 4, which is 4. What two numbers equate to this? You will get minus 4 and minus 1, okay? Yeah, so, sorry, my voice is a bit... So substitute this in place of your b. You will get x squared minus 4x minus x minus 1x, plus 4. This is equal to y. Now, how do we find the x-intercepts? We make y 0, so 0. First, let's factorize this. Y, factor out x minus 4, and this has to be x minus 4 again. So what comes in between? It'll be a minus 1, so a negative sign. So fully factorize this will be x minus 1, x minus 4. Make y 0, you get x minus 1, x minus 4. So we take each of this, x minus 1 is equal to 0, x minus 4 is equal to 0, so x will be equal to 1 and x will be equal to 4. That's our our x-intercepts confirmed. How do we get the y-intercept? We'll make x 0, so it is going to be y is equals to, let's just put it here, okay? 0 minus 1 and 0 minus 4, you get 4 is your y-intercept. 4. So the graph is going to look like this. Okay. That's how we do that. Quadratic graphs. The discriminant now is another thing that we need to know. Discriminant is basically going to be, so discriminant is b squared minus 4ac. B is going to be, let's take an equation, y is equal to ax squared plus bx plus c. So b squared minus 4ac. When you take b here, when you take a here, and when you take c here, if your value of b squared minus 4ac is greater than 0, that means that there is 2 real roots. That means that the graph cuts the x-axis twice, okay? Either like that or like that. If it's b squared minus 4ac is equal to 0, that is 1 real root. So it'll be looking like this, either like this or like this. So it'll just be touching the x-axis once. And if your graph, let me just leave that there. If your graph is b squared minus 4ac is less than 0, that means no real roots, or your graph is basically going to look like this or like this. Yeah, so that is the first 2 chapters. In the next video, we'll look at chapter 3 and chapter 4, and then in the next 2, we'll look at chapter 5 and chapter 6, and then finally we finish with chapter 7 and chapter 8. So that is a 4-part video. This is part 1 of it, and this is everything that we need to know, okay? In very extreme detail from the textbook itself.